So it's great to be here. Thanks everyone for having us. So first of all, great conference, and all these new developments that are coming out, especially in video. It's just exploding. There's a lot of new progress in photogrammetry, and so everyone's pushing forward for the content for these immersive headsets, which is really driving the industry. And again, congratulations to Colour and their recent announcement. So NCTech has been a little bit busy too. Thanks to Charles for announcing one of our latest developments, which is the new Iris camera. So I'd like to just walk through a little bit more about that product and the workflow, the technical specs, and why that product has come around. So really the focus of NCTech has always been about creating high-resolution images autonomously, using, having very little user involvement, just producing a 360-degree panel which, may be used for business, commercial purposes, not so much for it's not something that's their main part of their everyday job. So that's why NCTech has been heavily focused on and successful in the engineering sector, the surveying and forensics and other markets, such like that. And we've developed a lot of technology and experience in those markets, and we kind of created a rod for our own back because we went into engineering, which is a precision industry, and so our products had to perform to the very highest levels to work with surveyors and architects, where they're using high performance £100,000 laser scanners for LiDAR capture. So our products in that area has really driven a lot of technical innovation in our small team and our company, and so we wanted to just sort of bring to your attention some of those developments and how that's kind of transcended into this new product Iris that we've been so excited to tell everyone about. So following discussions that we've been having with Google over the last several months, it was apparent that there was a need for a quick 360 high-resolution camera that was portable and easy to use, so that lots of people could be capturing data in huge numbers of amazing images from all over the world. This is something that Luke touched on when he showed the map and how they've got a long way to go, and we're right behind that. The more we can help in that area, the better, But the big problem for us was the price. When you create a high-end, your DSLRs are the price for a reason. They're a complicated piece of kit and they're very high, quality. So we needed to look at our product and think, okay, can we make a more consumer level product but still give that high quality that Google and others would need? So price was the big issue, so we had to overcome that. And also, we needed to know if this product was made, the concept is a good idea, but would it actually work in the real world? So the only way we could find that out is to create a pilot project. So what we did is we produced some prototype product, and we started, as part of our development, to test images across Europe. And just using 3 beta cameras over a period of 3 to 4 months, we equipped our photographers and asked them to just go and see what businesses would be interested in this type of thing. Just canvas large areas, no real workflow other than these are the areas you're in, go door to door, and let's see every business, every single business, not being selective in any certain way. So we targeted all the high street businesses, but typically smaller businesses like local gift shops, newsagents, delis. These were businesses that we felt were often considered to have no budget, or why would you want to look at a fruit and veg store on Google Maps? I would quite like to see a fruit and veg store in Google Maps. So it's just, you know, hotels, restaurants, these things are quite common, but the little outlets that give character to a street, to a town, these would be great to see as well, especially if they're all hooked in Street View. So we took a number of images. There's a small selection here of a fishing shop, an art shop. So really anything would go, anything was up for grabs. We weren't really looking at this as a way of conforming to any set of rules that were put down, but the results were very encouraging. And all the images that are on our system, which we uploaded to Street View, every single image was paid for, because there was no other way to make a proper pilot test. There's no point giving away free images, because then everyone will say yes. So we've got to really find out who's prepared to pay, and is the image good enough, and is the hole on the ground small enough for them to accept it as a representation of that little small business online. So within a period of only 4 months, using 3 cameras, we generated over and sold over 2,000 panoramic images. The aim of the project was to see how successful it would be, and only using Google Street View as the final deliverable. We weren't selling Facebook and all these other social medias and their website, and we weren't doing value-added services. We were only saying, if we could put you on Street View, would you buy an image? So most of these shops and businesses didn't even have their own website, and they wouldn't know what to do with a link if we sent them one. So we just simply published the images to Street View for them. However, we feel the results could have been significantly better if we had trusted photographer status at the time when we did the pilot, and also the way we were, because it was a pilot and we were using a prototype, we didn't have our software quite ready at that time. So all the processing was done on a laptop afterwards. So our day would be structured whereby the photographer would go in the morning and take some images of some shops in a street, in a high street. Then they would go back to their car or their apartment, process the images during siesta, if it's in Spain, and then they'd go back in the evening and present the images and see if the business owner would like to do that. With the new product, obviously, our intention is to have all of that running on board the camera so that it can be done there and then, live at the time you're capturing. So, what is this new camera? The new camera it's all about automation. It'll never compete with, you know, your professional photographer with digital SLR. We fully understand that. It's not about trying to compete, it's just another tool to provide data very fast and of an acceptable quality that businesses are happy to include as part of their marketing. So, to begin with, it's an 8K resolution with full onboard processing, with dynamic stitching, and there's no moving parts. This was mentioned by Luke earlier, where you're capturing huge volumes of data and you've got a shutter. That shutter eventually, you know, it's a moving part, it could break. So our camera has no moving parts. And again, it supports the open spherical camera interface, which was announced earlier with Charles today as well. So we're very pleased. I think this is one of the first cameras to support that. So moving forward, how do we control it? Well, the great thing about onboard stitching is it means that you can use a tablet, a phone, any Wi-Fi device, and especially the new app from Google, using the new API, which is a great way of controlling the unit. But the product comes with its own interface, and any tablet you'll pull up this interface that you see here, and with the onboard stitching, you'll get an instant immersive viewing experience at the resolution that you capture at. So at 8K resolution, it'll push over a fully stitched, blended, immersive HDR image over to you that you can show immediately to whoever it is you're taking the picture for. But this wasn't available during the pilot project, but again, we think this would have been really helpful in our numbers if we had it at the time. So to go through a little bit of the tech spec on the camera, it's quite powerful. It's got 8 cores, 2 GHz processing, GPU, and it's got GPS on board, and it supports numbers of GPSs. But it also has USB 3 on the go. You can use it as a mass storage device, micro SD and HDMI. So that's the sort of the ports on it there. That's the boring stuff. So the Open Spherical Camera API, what is it? Well, we've been delighted to be working with Google, being part of that project with them, and this will really open up the doors to other manufacturers and developers to hit the ground running and test their code using camera simulation and functions, debugging their code so that they can deploy whatever tools, hardware or software tools that they're going to release to the market. The Open Spherical API is now available for download on the NCTech website. So it's available for download from our website, and it's free of charge under the GPL. So really pleased about that. So and again, the full documentation is on Google's developer website. So fill your boots, as one of our guys would say in the office. So moving on, the technical challenges was one of the main things with this product. Like any product, it's great that you can maybe build one. You know, building a prototype is fine. You know, you can hack it together from whatever you have handy on your desk. But knowing that you're going to scale up this product, and certainly, you know, this is the full intention with this product is to scale it. With NCTech, the markets that we've been in, they're very exclusive sort of commercial markets. So each product that we have, we can customize it, tailor it to all the individual needs of all these businesses. But with consumer product, we fully understood from the outset that, you know, this is going to require quite an effort behind the scenes to ensure delivery, fulfillment, manufacturing, support. All these things are in place on a much grander scale than what NCTech has done before. So with scale came those challenges. So what we did is, with any camera, you know, you've got to focus lenses. This camera has no moving parts. So with the lenses, they're all set at a fixed infinite focus. So every single lens, and there's 4 of them per camera, you know, that's thousands of lenses that need focused. If that was given to an individual to do as their daily job, they would probably be not very happy about it. They'd probably go blind. So with that, we had to devise an automatic way of focusing these lenses. So we wrote software, we did, you know, all this sort of stuff, motorized units, and allowed us to scale up our focusing rigs. Calibrating those lenses, we had to develop a way of really fast calibration of every camera that we ship. And I'll come on to why we calibrate in a few extra slides, but the reason there is we want accuracy in what we're taking a picture of, but we want accuracy in our stitch as well. So calibration is essential, and right down to how the light is entering the lens, and these things needed to be done in a large room that we developed. With every camera takes a picture in the middle of that room, and then our software auto-detects over 850 surveyor's targets inside that room, and rebuilds the environment that it's in to sub-pixel accuracy. So that was something we had to develop, and we had to streamline that as well, make it really fast. And then things like parallax error as well. With a camera that has multiple lenses, there's no fixed nodal point of rotation, so we needed to resolve parallax error if we were going to produce a great stitch or image in a confined space. Good news is we did solve all those issues, and they're all running on board Iris. So what else is running on board Iris? We've got HDR. Now HDR is something that you guys will be well aware of. With the challenges of 360 imaging, you don't have the ability to look away from the sun. It's, you know, it's there as well as dark areas. So you need to do bracketing and exposure fusion. So again, we developed an algorithm that automatically checks the entire range throughout the range and changes a dark image into a fairly vibrant image. And that all happens on board the camera as well, fully automatically. So again, when you're doing street view imagery, where you're inside a restaurant, this is going to be extremely important. I mean, to see outside those windows where they're not, you know, it's not blown out and overexposed. So range finding. This is something that we developed last year, and again, as part of this project, we were really keen to get it ported over onto Iris. So we spent some time, and we now as part of our development in our commercial industry, where we're working with laser scanning technology and our calibrations that we do there to quite a high degree of accuracy, we transposed some of the IP over and we felt, okay, we'll range find from within the scene. So it's very similar in the sense of you know, the jump system from Google, where they have an array of cameras and they create multiple virtual points. We're doing the same, but we're doing it from one camera. We're not doing video, we're doing one image. So we don't need thousands of computers, thankfully. We can do it all on board the device itself. So from this image here, we generate a range map, and then from that range map, anything that's close is in white, and anything that's far away goes to dark. And from that, we can calculate distance, and then from that, it can help us with our stitching and correct for parallax. So, moving on from range finding, what else do we do? So, here's an image which is actually, this is an early prototype video. We've got some new stuff now, but I'll focus on this for the moment. So last year when we developed this, we explored about finding depth information from within panoramas. So what we've done here is we've taken a single shot from iStar, and then we moved the camera slightly and take a second shot just to give us extra overlap from what we see. And then from that, it's managed to, hopefully if it runs, we should be able to see a little bit of depth information from the scene. So we'll just zoom down, look around, see the quality of it. But then, as you move slightly, you should be able to see a little bit of range information coming through the picture. So it was working. You obviously get black areas where the camera hasn't seen behind that. So if you move the camera and you take a few more shots, what will happen? Well, you'll build a much more depth in 3D model with millions of points of data. And so you can actually construct an entire 3D model just from 3 iStar images. We moved. Thank you. So yeah, so that surprised me there. I wasn't expecting that. So the good thing about this is we spent, to create that takes no time. So when the user takes a picture, takes another picture, our software will auto-register those images, create the 3D model, colorize it, and export it all for you in 2 minutes. So it's an incredible, powerful program that we've developed there. Moving forward, this next little clip that I've shown is from our work in the laser scanning field, where we're actually working with real LiDAR data. We're not generating it ourselves. We're actually pulling in real measurement information. So the next slide here is a little video where the black and white information is the range information that you saw in the last slide. But now we'll blend in our color. And that's, again, processed fully automatically with no user input whatsoever. You take the scan, you point to our images, boom, it's done. Minutes, 3 or 4 minutes to generate what is possibly 100 million points of data easily there. And that is millimeter accurate. Thank you.
How many pictures it took to do that?
Sorry?
How many pictures it took to get that?
To take that was 7.
7 only?
7 around the church. Yeah. So the main thing here is it's automation. NCTech is automation. We're not into, oh, you've got to click this menu, do that, and it's just drag and drop, bang, that's it. With this, the main thing that we see here is people look at our devices and go, you've got fisheye lenses, you're going to have chromatic aberration, you're going to have parallax issues. Look at the data we're producing for the engineering sector here. It's not about looking at the imperfections of the device. We can solve that in software. And we have done. We've removed the chromatic aberration. We only use the best bits of the lens, and we only use the best pieces of information from each scene. And then we blend it all in, cross-reference it, auto-register it, and there's no parallax, and there's no stitching errors in any of these 3D models because we don't do stitching. So that kind of sums up what our developments have been on. The new camera is available to order today, $1,999. We'll be shipping in a couple of months. Thanks for your time. Thank you.
Any question?
First of all, thanks very much for your presentation. Pretty impressive point cloud over here.
Thank you.
I'm just curious about the file format of the point clouds.
Yeah. At the moment, what we've done is we don't want to spend too much time figuring out user interfaces. There's already a lot of them out there. Can you hear? Is this still? There's a lot of good companies out there who already work in the point cloud market. You've got Autodesk, you've got VSys, there's all these great companies out there. So what we've done is we've actually teamed up with all those guys over the last couple of years. And so we've created a plugin. And so what you saw there was achievable in our own software, where you drag and drop the data in and it generates a file format that we were happy with, which was E57 or an LAS file, which is a fairly generic file. But we knew that to convert, you know, if you're using a Leica system or a Faro or a Trimble, they have their own file formats as well, and you want to stay in their native software. So we wrote a plugin, and we sent that plugin out to all these manufacturers, and today we've already got Trimble, Leica, VSys and Autodesk fully implementing our technology into all their applications, so that when you have an iStar or potential new iStar products, those images will just come straight into that software and you'll just see it colour within your native program, so you don't have to worry about file formats. It'll just support our own native images straight from the camera. Does that answer the question?
Thank you.
Great.
Impressive work. I'm really glad to see this stuff becoming a viable product. I wanted to ask you if the depth map, which is a very nice clean depth map indeed, is equivalent to the point cloud or is derived by a different kind of algorithm?
The depth map algorithm that we've developed runs on board Iris, and it now runs on board iStar cameras. The iStar cameras are 50 megapixel, and there's new things coming in that era too. Iris is running at 8K at the moment, and the depth map is slightly different. The lens configuration is slightly different with Iris also, just due to trying to get the cost down on the product to make it consumer. But we tried our best to port over as much of that IP on board this device as we could, but without taking it too far that it would take 10 minutes to process an image. So, you know, when we're working with architects, they're using quite powerful PCs with, you know, gigs and gigs of RAM, and you know, they're throwing around these huge point clouds. So to process in 2 minutes is nothing for those guys. It's hardly enough time to put the kettle on, you know. Whereas with this, we need the photographer to have it as fast as possible, so that he can present that, show it, move on. And so we've scaled it back a little, but the depth map is very similar. It's the same algorithm, just pulled back a little bit from what we're doing because we don't have quite the resolution here.
Do I understand you correctly to mean that the Iris does not spit out point cloud, only the iStar spits out point cloud?
At the moment, we're not spitting out point clouds from Iris. It's doing it internally to give you a better stitch and correct for parallax. But at the moment, until this product comes out, we're trying to, you know, we've got an engineering sector there that has a product called iStar that's designed for that. We don't want to bring out a product that, you know, potentially, you know, the iStar's a higher resolution product. We don't want to bring out a lower end product to compete with that at this time.
Another question.
Hi.
It's my birthday. Sorry.
You know the funny thing? It was my birthday yesterday.
Congratulations on what you've achieved. It's quite amazing, and I think nobody's thinking about the big nugget hole anymore.
Yeah.
Or maybe just a little. But how is there, like, in the future, a web-based application available in which you can offer these 3D models and take measurements within them?
Well, yes. We have, if you go to our website, we just put our website live as you're in here. So we've got a brand new website. It's went from black to white. We've got Iris on the homepage. We've got Google highly featured there. Those guys have been fantastic to work with. Really appreciate that. And we have got there is systems there at the moment called iStar Share. And it's a platform that's there for hosting your images and sharing and creating, all sorts of stuff for sharing images. The plan is that coming soon we are going to be revising that platform, and it's going to include much more of the 3D spatial content that we're generating now. So that's something that we internally have been aware that we've needed to supply. We're currently working on it. It'll be something that comes out soon. Yeah, these products are not shipping until August, mid-August onwards, so it gives us a few months to just get these systems moved over.
Sorry, just on the Nadir hole.
Yeah.
Having seen the point cloud, I'm just gobsmacked with that. It's amazing. So please make it available out of this. But how feasible it would be to take 2 shots to fill the Nadir hole, basically just offset the camera?
Quite easy. That's the whole point. We don't bother about the Nadir, and we're probably not going to try and address it in optics, because you can just move the camera. It's so quick. Yep. We can fill it in software. Google are doing that anyway with Street View. So it's certainly something that we will do. There's I don't want to say too much at the moment, but there's a lot of new things that we are bringing out this year that will probably be very exciting. There's other products out there that do like the Matterport systems and things like that are available. There's new things coming from us that will probably address a lot of that as well.
Yeah, so we have the Matterport.
Oh, you do?
Yeah. And so I'm quite familiar with this. It's clearly moving extremely quickly.
Yeah.
But what you have there is quite astonishing. If you can automate the filling of that hole, then you're not going to get me whinging about it like I was.
You weren't whinging, were you? Will do. Thank you. I'll take your point forward. Thank you.
Hi. Just a quick one. Very good, excellent. Thanks so much for down here, by the way.
Thank you.
And I just wondered about is there any sort of manual triggering? I know you've got an app that will go with this, but is there ways around? Is there like an in-out port that you can basically trigger the thing in exactly the way you want it?
Yeah. The way we can control this at the moment is by two ways. There is a physical button on it, but then you're on a timer. There's the web interface that we've built in, or there's the API at the moment. We also do have an SDK that we developed for iStar for mobile mapping. So currently people put these on vehicles and take so many images as they drive. These cameras already support extended GPS functionality, so and even nautical GPS as well. So whatever you plug into the USB ports, it'll stop using its own internal, and it'll start reading in that high accuracy from an IMU or your inertia unit. It'll start reading that in. So to answer your question, yes, you can trigger it, but at the moment, because this is a brand new product, we don't know how many of these high-end things that we've done in iStar we're going to allow to be compatible with this product, because we've got, there's other things coming, and we need to just kind of stagger our release so that we can get a nice platform out there. I know what you guys are after. I think this is some way towards that, but I think there's probably, if you're getting into that sort of area, there's probably other things that would probably satisfy you a little bit better than that.
I'm remiss that I don't know the answer to this, but in which countries can we purchase these cameras?
Well, what is the countries we can purchase this in? Andrew, do you know?
Worldwide.
Worldwide, is it? Worldwide delivery, there we go. Great. When can you start? Is the website up, the purchasing? It's live. Okay. Great. Not now.
Another?
So, I'll come to next.
Okay.
Just a practical issue. How do you not get in the picture when you're making them?
It's funny that we, very early on, on iStar, for example, which has a touch screen on it. This device doesn't have a touch screen. That's not a screen. It's an on-off switch up there. But the way you not in the picture is we have a thing called walk-around mode. yeah? And once you're in walk-around mode, it tells you to get out of the way, and then it takes another picture and fills in the gap. So it'll capture half of the scene, and then you move, it captures the other half, and then it blends the two together. So it saves you hiding under the tripod and running away. Yeah.
We're curious about would artists shoot videos, props? No? Because I know iStart is just all about imaging.
You're sitting next to Colour with GoPro. You want video, there's your guy. But, you know, it's a good question. No, we didn't design this product for video. Yeah.
And as we know, on IVRPA 2015, most of the manufacturers will have a coupon code. So if we pre-order the device during the meeting, we'll have a coupon code?
I think so, yeah. We'll set that up for you. So everyone in the IVPRA will put a product code up. So if you do order, we'll do something on the price for you. Not much.
Okay, great. Thank you very much, Neil.
Thank you.
Great
Thank you, guys.
product.
Thank you.
So we were supposed to get...